Welcome to our journey through the fascinating world of physics. Physics is the fundamental science that seeks to understand the laws governing the universe, from the tiniest particles to the largest cosmic structures. In this video, we'll explore the different genres of physics, each uncovering unique aspects of the natural world. We'll start with astrophysics, which examines the stars, planets, and galaxies that make up our universe. Then we'll delve into particle physics, where we investigate the smallest building blocks of matter. Next, we'll explore electromagnetism, the study of electric and magnetic fields and their effects on matter. Classical mechanics will take us through the motion of objects and the forces acting upon them. Acoustics will reveal the science of sound, while thermodynamics and statistical mechanics will show us the principles governing heat and energy. Physical chemistry bridges the gap between physics and chemistry, exploring how physical laws affect chemical reactions. Nanophysics focuses on the behaviors of materials at the nanoscale, leading us to quantum mechanics, where particles behave in ways that challenge our everyday understanding. Relativity, both special and general, reshapes our concepts of space, time, and gravity. Biophysics applies physical principles to biological systems, helping us understand life at a molecular level. Finally, geophysics studies the physical properties of the Earth, from its core to its atmosphere. Together, these diverse fields of physics provide a comprehensive picture of the universe and our place within it. Let's dive in and explore the wonders of physics. Let's begin with astrophysics. Astrophysics is the branch of physics that studies the universe and its celestial bodies, including stars, planets, galaxies, and black holes. Astrophysicists use the laws of physics to understand how these celestial bodies form, evolve, and interact with one another. They explore questions like, how do stars ignite and what determines their life cycle? What forces shape the structure of galaxies? How do black holes form and what happens at their event horizons? By studying light and other forms of electromagnetic radiation from these objects, astrophysicists unlock the secrets of the cosmos and expand our knowledge of the universe. Next, we'll delve into particle physics. Particle physics, also known as high-energy physics, investigates the smallest building blocks of matter and the fundamental forces governing their interactions. This field seeks to understand particles like quarks, leptons, and bosons, which combine to form atoms and other complex structures. Particle physicists use powerful accelerators to smash particles together at high speeds, revealing new particles and interactions. Key questions include, what are the fundamental particles that make up the universe? How do these particles interact through the fundamental forces of nature? What is the origin of mass, as explained by the Higgs boson? By uncovering the properties and behaviors of these tiny particles, particle physics aims to reveal the underlying structure of all matter in the universe. Moving on, we have electromagnetism. Electromagnetism is the study of electric and magnetic fields and how they interact with matter. This fundamental force governs a wide range of phenomena, from the behavior of charged particles to the propagation of light. Electromagnetism is responsible for the electricity that powers our homes, the magnets that hold notes to our refrigerators, and the wireless signals that allow us to communicate. Maxwell's equations describe how electric and magnetic fields are generated and altered by each other, and by charges and currents. Applications of electromagnetism include everything from electric motors and transformers to radio waves and lasers, making it a cornerstone of modern technology and physics. Classical mechanics will take us through the motion of objects and the forces acting upon them. This branch of physics, based on the principles laid out by Isaac Newton, describes the physical laws governing the movement of bodies under the influence of forces. It covers concepts such as inertia, momentum, and energy. Classical mechanics explains why planets orbit the sun, how a ball rolls down a hill, and why a pendulum swings back and forth. It includes Newton's laws of motion, which describe the relationship between a body and the forces acting on it and the resulting motion. Classical mechanics is fundamental to engineering, architecture, and many areas of science and technology, providing the tools to analyze and predict the behavior of physical systems in our everyday world. Acoustics will reveal the science of sound. This branch of physics deals with the production, transmission, and effects of sound waves. Acousticians study how sound waves travel through different media, such as air, water, and solids, and how these waves interact with surfaces and objects. Applications of acoustics range from designing concert halls to enhance sound quality, to developing ultrasound technology for medical imaging, to understanding animal communication. By analyzing sound waves and their behavior, acoustics helps us improve everything from audio technology to noise control in our environments. Thermodynamics and Statistical Mechanics will show us the principles governing heat and energy. Thermodynamics focuses on the macroscopic properties of systems, such as temperature, pressure, and volume, and how they change during physical and chemical processes. It introduces concepts like entropy and free energy, which help us understand the direction and efficiency of these processes. Statistical mechanics, on the other hand, connects these macroscopic properties to the microscopic behaviors of individual particles. It uses probability theory to predict the behavior of large numbers of particles, providing a deeper understanding of phenomena such as phase transitions and heat capacity. Together, these fields explain how energy is transferred and transformed in systems, from engines and refrigerators to biological organisms. Physical chemistry bridges the gap between physics and chemistry, exploring how physical laws affect chemical reactions. It involves the study of molecular and atomic interactions, reaction kinetics, and the properties of materials. Physical chemists use techniques from both physics and chemistry to understand how molecules behave and interact under different conditions. This field provides insights into reaction mechanisms, helping us design better catalysts, develop new materials, and understand biological processes at a molecular level. By applying physical principles to chemical systems, physical chemistry advances our ability to manipulate matter and create new technologies. Nanophysics focuses on the behaviors of materials at the nanoscale. This field examines how materials behave when their dimensions are reduced to the nanometer scale, typically between 1 and 100 nanometers. At this scale, materials exhibit unique properties that differ significantly from their bulk counterparts. Nanophysicists study these properties to develop new technologies in electronics, medicine, and materials science. For example, nanoparticles can have enhanced electrical, optical, and mechanical properties, making them useful in creating more efficient solar cells, targeted drug delivery systems, and stronger materials. By understanding and manipulating matter at the nanoscale, nanophysics opens the door to innovations that can transform various industries, leading us to quantum mechanics, where particles behave in ways that challenge our everyday understanding. Quantum mechanics describes the behavior of particles at atomic and subatomic scales, where the classical laws of physics no longer apply. In the quantum realm, particles can exist in multiple states at once, a phenomenon known as superposition, and can become entangled, meaning the state of one particle is directly related to the state of another, regardless of distance. Wave-particle duality reveals that particles, like electrons, exhibit both wave-like and particle-like properties. Quantum mechanics has led to the development of technologies such as lasers, transistors, and quantum computers, and continues to revolutionize our understanding of the universe at its most fundamental level. It challenges our perceptions of reality and opens up a world of possibilities in both theoretical and applied physics. Relativity, both special and general, reshapes our concepts of space, time, and gravity. Special relativity, introduced by Albert Einstein in 1905, revolutionized our understanding of space and time by showing that they are interconnected and relative to the observer's state of motion. Key concepts include time dilation, where time slows down at high speeds, and length contraction, where objects appear shorter in the direction of motion. It also introduced the famous equation E=mc², which shows the equivalence of mass and energy. General relativity, published by Einstein in 1915, extends these ideas to include gravity. It describes gravity not as a force, but as the curvature of space-time caused by mass and energy. Massive objects like stars and planets bend space-time, creating what we perceive as gravitational attraction. This theory has been confirmed by numerous experiments and observations, such as the bending of light around massive objects and the detection of gravitational waves. General relativity provides the framework for understanding the large-scale structure of the universe, from black holes to the expansion of the cosmos. Biophysics applies physical principles to biological systems, helping us understand life at a molecular level. This interdisciplinary field combines methods and concepts from physics, chemistry, and biology to study the structure and dynamics of biological molecules and systems. Biophysicists investigate how proteins fold and interact, how cells communicate, and how energy is transferred within organisms. By using techniques such as X-ray crystallography, nuclear magnetic resonance, and fluorescence microscopy, Biophysics reveals the detailed mechanisms underlying biological processes. This knowledge is crucial for developing new medical treatments, understanding disease mechanisms, and designing biomimetic materials. Biophysics bridges the gap between the physical sciences and biology, providing insights into the fundamental processes that sustain life. Finally, geophysics studies the physical properties of the Earth, from its core to its atmosphere. Geophysicists explore a wide range of phenomena, including the Earth's magnetic and gravitational fields, seismic activity, and plate tectonics. By examining the movement of tectonic plates, they help us understand the causes of earthquakes and volcanic eruptions. Geophysics also includes the study of the Earth's interior structure, using seismic waves to reveal details about the composition and behavior of the core, mantle, and crust. Additionally, geophysics encompasses the study of the Earth's atmosphere and its interactions with the solar wind and cosmic radiation. This field is crucial for predicting natural disasters, managing natural resources, and understanding climate change. By studying the physical processes that shape our planet, geophysics provides insights into the dynamic systems that sustain life on Earth. Together, these diverse fields of physics provide a comprehensive picture of the universe and our place within it. From the smallest particles to the vastness of space, physics helps us unravel the mysteries of the natural world and drives technological advancements that shape our future. Thank you for joining us on this journey through the many fields of physics. We've explored everything from the vast cosmos in astrophysics to the tiniest particles in particle physics, the invisible forces in electromagnetism, and the laws governing motion in classical mechanics. We've delved into the science of sound with acoustics, the principles of heat and energy in thermodynamics and statistical mechanics, and the intersection of physics and chemistry in physical chemistry. We've uncovered the unique properties at the nanoscale in nanophysics, the strange and fascinating behaviors in quantum mechanics, and the revolutionary concepts of space and time in relativity. We've seen how biophysics applies physical principles to understand life itself, and how geophysics reveals the inner workings of our planet. These fields, though diverse, are interconnected, each contributing to our understanding of the universe and our place within it. Physics not only helps us comprehend the natural world, but also inspires innovations that improve our lives. If you found this video insightful, please give it a thumbs up, share it with fellow science enthusiasts, and subscribe to our channel for more intriguing explorations into the wonders of science. Stay curious and keep exploring.